Hello there, it's Keith here, and this is lesson 5 of the Hello World series of my ARM assembly programming tutorials, and today we're going to run Hello World on RISC OS. But wait, I hear you say, you've done that already. Well, sort of, I have. Last time we assembled a Hello World example using the Windows tools and transferring to our emulator. Now this time we're going to do it directly within RISC OS itself, because RISC OS has a copy of BBC Basic, and this version of BBC Basic can actually assemble programming language. So we're going to assemble our program within RISC OS itself. We're still going to use Windows for creating the text file, and we're going to transfer it via the hostfs file system, but we're going to actually run the program itself within Basic. And if you wanted to do a lot of typing within BBC Basic, you could do the exact same thing and run the program in Basic itself. So that's what we're going to be doing today. Now, if you're new to my channel, I do have to advertise my book. I have a book on assembly language. I actually have two, and the first one covers Z80, 6502, 68000, 8086, and ARM. It's a basic programming language book. It covers all the essentials of those assembly programming languages, so please take a look at that if you want to see that and support my content. Anyway, enough shelling. Let's get over to the source code. Let's take a look. Now, before we look at the source code itself, we're going to discuss how I've actually set up my emulator. Now, if we start my emulator here, you will see when it actually starts up, we've got hostfs already set up. Now we've got this basic icon here which I've created, and this will actually start the ARM BBC Basic system, and it will automatically load a file from the file system. So if we do list here, now we do need to use uppercase for basic commands. BBC Basic is case sensitive for some reason. You can see we've actually got a program already loaded in here. So first of all, what we're going to do is we're going to create that basic icon, because that's going to save us a lot of time. So let's just quit out of Basic here for a moment, and let's see what that actual file does. So within the host file system folder of Windows, this is actually appearing as a drive on the RISC OS system, and it's this basic feb file. Now please note that this is basic comma feb, not basic full stop feb. The file extension is feb. That is a script file on this system, and so that is what we're going to create, but we do have to have a comma, not a full stop, to denote the file extension and type. So what this file contains is the command basic. This loads the basic interpreter. -load is telling the basic interpreter to load a file. Hostfs : is the drive effectively that we're loading from, the host file system, which I've got the emulator set up to link to a drive, to a folder on the actual Windows system. And then the file we're specifying is basic file with no extension or file type. So that is what we're loading. Now, if we load up basic file here, and if we turn on, we're just going to show the carriage returns on line feeds and things. You'll notice we're using Unix format. So there's an LF at the end of each line, no carriage return. That is important, I believe. I believe that it will actually cause problems if we have carriage returns in there. The other thing that was causing problems is the tab symbol. So don't be putting any tabs in there, because it seems that the assembler doesn't like them. So we've got no tabs, we've got spaces, and we've got line feeds, and that will all work quite nicely. So what we're going to do first, before we go to that complex example, is we're just going to replace the contents of basic file with this very simple example here, and we're just going to save that. So the one we're running here is basic file minimal. And if we just go back to our emulator here, and we just rerun basic again here, and we do list, we will see that the contents of that file that's been loaded have now changed. I'm having a little bit of trouble because of the mouse capture here with my zoom, but you can see here this is the program we're running now, and we're just going to type in run here. This will effectively assemble the program. You can see we've got the assembly occurring there. It says assembled, no errors. And now if we want to run this program, the last line of my basic actually showed the address that the program was assembled to. So we can do call 37012. And you can see nothing actually happens and it returns. That is actually correct. This program literally just returns back to basic. Absolute minimal example. Or we can do call MC%. MC% has been set by the basic part of our program to the address of the start of the code, you can see. And once again, it's just returned back to basic, which is what this program is supposed to do. So let's just quit out of basic here. Let's just quit out. And let's go back to our code, and let's just see what this program has actually done. So this is the file we've just assembled. Now, the important thing is that the assembler has to have a small basic block to actually do the work of the assembly for us. So we're going to look at that basic block first. Now, the first line is a dim command here. Now, this is defining MC%, but this isn't defining a conventional array. Usually you'd have brackets and a number. This is actually defining a block of memory. So this is telling the operating system to allocate us some memory. We are specifying a value of 1000, but this actually, I believe, allocates 1001 bytes. So MC% now points to a block of 1001 free bytes. What we've got next is a loop. Our loop variable is called opt%, and it starts at 0 and it goes up to 3, but it only runs twice, so it will run only with opt% equals 0 and opt% equals 3. So this is going to run for 2 iterations. Now you can see the next statement here, and after that our assembly is actually completed, and we're just showing MC% to the screen. Now, what this actually does is this is running a 2-pass assembly. If you don't know about assemblers, what typically happens is the first pass is actually just looking at the code and working out where the labels appear, because and jump to a label at the start of our code with a label at the end of our code. When that jump is experienced the first time by the assembler, it won't know what value that label has, but then the second time, in the second pass, it will know what value that label should have because it's seen it in the first pass later in the code. So we're doing these 2 passes, and what this is doing is it's setting the settings for the assembler and telling them the first pass ignore the errors, and the second pass, if you still don't know what that label means, you should, so fail basically. Now, because we're doing 2 passes, we need to set the program counter up for the assembler correctly. Now, p% is the program counter for the assembler. So this p% equals MC% is saying at the start of each iteration of the pass of the assembler, set the program counter to the start of the free memory. That's what p% equals MC% does. Now, after that, you can see we've got a square bracket here, and here we've got another square bracket. So everything between these 2 square brackets is assembly language. Now, the first line is opt. Now, this actually is an assembler directive, and this is telling the assembler, set your options, and then this opt% is the same one that's in BASIC here. Opt0 means ignore errors. Opt3 means if an error occurs, fail, and also output the listing to the screen. So that is telling the assembler what to do with this pass of the code, because as I say, this loop will occur twice because of that command there. Now move PC, R14. R14 is the link register, so that's the return address. And so what move PC, R14 actually does is it effectively returns back to BASIC. So you would want to replace line 110 onwards with actual program code that you want to assemble if you had an actual program to do. And then the final thing we're doing is we're just showing MC% to the screen here for my convenience, so I can see where the code actually went. So that's our absolute minimal example. Now, the final thing we got here is some comments. Now, these are basic comments. Colon means a new command on the same line, and rem means remark, so everything is ignored by basic here. These are assembler comments, these are the assembly version because they're within the assembly block here. We can use a semicolon. We can also use a slash, I believe, so either will work just fine. And that's our absolute bare minimal example, but that's not what we're here for. We're here for hello world. So let's copy this much larger example here, and let's put that into basic file. Remember, basic file here is the file that's assembled. These are just my test files that I'm copying and pasting from. So if I now save this here, if I just do a file save, and then we go back to our emulated system here, and we're just going to rerun this basic here. We're just going to rerun that. I have to disable my zoom because the mouse capture is playing it up. So we've now got our emulator running basic again, and if I do list, you can see we've got an awful lot of code now. This is my hello world example, and if we just do run, we've got a syntax error, line 410. That's a bit odd. Let's have a look there. Oh dear, I've made a mistake. I've put some tabs in. I got carried away and put some tabs in instead of spaces. So let's fix those right now. As I say, the BBC assembler seems to have some problems with tabs, which I guess is fine. You know, I'd prefer it didn't, but if that's the way it works, that's what we have to do. So let's just fix our code up here. Let's just save once again, and if we just quit out here, we don't need to reload our emulator, we just need to reload our basic here, and if we do run again, you just run here, we now have no errors here, so our program has now assembled fine. And if we do call and we do MC%. Again, we could use the address that's been assembled to, but call MC% has the same effect. And we get a nice hello world message to the screen there. So we have now fewer bugs and we've now got a working example. So there we go. So that's how we can assemble our program. And that's how we can basically wrap our program within some BASIC and get it to assemble. Now what we're going to do now is we're going to take a look at the changes I've had to make to my program to get it to work correctly. There weren't too many, it wasn't too bad. The first thing we need to do is with regards to hexadecimal. Now the BBC assembly uses the AND symbol as a prefix for hexadecimal. Interestingly enough, the same as the Amstrad CPC, which is the system I grew up with. So with this here, this SWI, we used to use OX03, but this time we've used AND03. That is hexadecimal 3 there. That is hexadecimal 0. Now, obviously, we didn't actually need to use the AND symbol there, but just for consistency we have. Now our labels need to be prefixed with a full stop, and quite interestingly, while I didn't find any specific documentation stating this, I originally converted everything to uppercase because BBC Basic requires uppercase, and so I converted everything to uppercase with the right click menu and uppercase, but actually I was getting error messages with the labels when they were entirely uppercase, although I couldn't really see anything in the documentation that said that was a problem. But I'm using lowercase labels here and that seems to work fine. So maybe the assembler mistakes uppercase labels as being some kind of basic commands or something. I'm not quite sure. Anyway, we've had to replace our tabs with spaces. We've definitely had to do that. Now the assembler understands the reference to PC, the program counter, but it does not understand SP or LR as register names, so we've had to replace those with R13 and R14. The other thing we've had to do is with regards to defining our data. We've defined a hello world string and we have to use EQUS to define bytes of data with string data. For byte data, our 255 there, we've used EQUB. And we've defined a pointer to this string, and so that's a 32-bit value. And this is EQUD, and I believe D stands for double word, 32-bit there. So that is defining a 32-bit value there. And then the final thing is we've got an align statement here. We don't specify a number. Align automatically aligns to 32 bits there. So that is that's the last thing we've had to do there. So there we go. So now what we're going to do is we're just going to have a quick look at our code. First, I'm just going to put a few carriage returns in here so that it's a bit clearer what's actually going on. Okay, so I've just added a few carriage returns there to make it clear what the sections of our code are. And what we're going to do now is we're going to just discuss them, each of them just quickly. Okay, so new line is the simplest here. This is the new line subroutine. This uses software interrupt 3. That takes no parameters. It's the OS new line function. Really, we've just given it a nice name there. That is the return statement, moving R14, the link register, back to the program counter there. So that's the simplest of our subroutines. Print string is a little bit more complicated. What we're doing here is we're backing up all of our registers and the link register onto the stack here. The stack is R13. We are restoring them here and restoring the link register back into the program counter there. So that is just the return and restoring the registers there. What we're doing here is we're reading a single byte in from R1, incrementing R1. We're loading it into R0. Here we're comparing to 255. I use character 255 termination for my strings. You could use 0 if you prefer. When we get that, we are jumping to print string done down here, which is returning. Until we get that, we are running the print char routine here. I've missed the print char routine. Here it is. So the print char routine uses software interrupt 0. That is the OS write character routine. And that will show R0 to the screen. So that's just printing a character to the screen, very simple there. And that's what we're using to print characters to the screen. Now, when we are starting our program here, we are storing the return address, R14, onto the stack here. That's what that is doing. And that's because we need the return address of basic so that we can return back to basic once we're done. We're then loading R1 from the hello world address pointer here. That is defined as a 32-bit value there. That's just a pointer to the actual string data we want to show. We are then branching to the print string and we are linking. That sets the return address basically. We're then showing a new line. And then this load program counter from the stack here, R13 is the stack. That is effectively the return to basic there. And that is calling our print string routine. As I've said before, here is a pointer to the string we want to show. So that's a pointer to hello world. That's the string we want to show, and the string is here. That's the hello world string, and that is terminated with a 255 character followed by an align to make sure everything's 32-bit aligned, just in case we had more program code after that, although in this case we don't. So that is the hello world example. That has been converted to BBC assembly here, and it works very well. Yeah, I'm not going to jump over and start using this assembler rather than the Windows one, but this is a very good assembler. I was really impressed with BBC Basic. I grew up with the Amstrad CPC. It had a very nice basic language in it, but it didn't have an assembler built in, and so most of the time I had the Amstrad CPC. I couldn't do any assembly. I was pretty young at the time, but I did very late on. There was a free assembler with a cover tape I got, but as I say, I would have loved to have this back in the day, and well done to the BBC, and I say the 6502 BBC as well also has this assembler. Really good learning tool and perfectly capable assembler, so definitely worth considering. Anyway, I hope you've enjoyed what you've seen today. Please like and subscribe if you have. I've got loads of the assembly tutorials. If this is the first time you've seen my site, I've got about 15 different assembly languages, and I've covered the vast majority of the most popular systems as well, so please take a look if this isn't what you want to continue looking at. Anyway, I hope you've enjoyed what you've seen today. Thanks for watching, and goodbye.